Hi folks, we're going to take a look at the solution to page 408, number 12b. So what they want us to do with this expression is to simplify it and state any restrictions on the variable. Okay, so here I see two logarithms with the same base being subtracted. I don't see any other coefficients, so I can actually apply the second logarithm law straight off. Okay, so I can rewrite this as the logarithm of x squared plus 2x minus 15 divided by x squared minus 7x plus 12. Okay, and so now I have the logarithm of this rational expression. So let's see if we can simplify this any further by factoring numerator and denominator. So here we factor the numerator, so looks like 5 and 3 should work, so it'll be x plus 5 times x minus 3. And the denominator, 3 and 4 will do the trick, so x minus 3, x plus 4, x minus 4. Okay, and so here we see that we can simplify the x minus 3's, those two factors on both the numerator and denominator, so we're left with logarithm of x plus 5 over x minus 4. Okay. And so here's a simplification, but of course we know that logarithms cannot accept any inputs. The inputs have to be greater than 0. Okay, so this is where again we got to be careful, because if we just work with this final expression, okay, so we need x plus 5 over x minus 4 to be greater than 0. So again, we use the fact that a rational expression can only change sign at its x-intercepts or vertical asymptotes. Okay, so here x-intercept of 5, vertical asymptote of 4. And if I just use these here, I see, well, if I choose negative 6, negative over negative is positive. If I choose something between these two, so 0 becomes positive over negative is negative. Okay, and then here anything greater than 4, positive and positive, so positive. Okay. But this is where we have to keep in mind that it's not only the final expression that needs to be satisfied, it's also the initial ones. Okay, so I'm going to see if there's actually more, if there's any more restrictions based on the original term. So I'm going to still use this same number line, okay, but I'm going to go above and below to try to figure out when these are positive. Okay, so here, this first polynomial, okay, is factors as x plus 5, x minus 3. So not surprising, I'm going to add in this 3 here. Okay, so I'll check the numerator up here, and then down here we'll do the denominator. Okay, and here we know that this is a parabola opening upwards. Okay, so it means when it's less than negative 5, it's going to be positive. Okay, and then when it's greater than 3, it's also going to be positive. So you think you have the parabola that goes below 0 between negative 5 and 3. Let's check this other one here. Okay, since again it's a parabola opening upwards, okay, it'll be positive for anything less than 3 and anything greater than 4. And essentially what we're looking for is we're looking for the intersections. Okay, where is everything positive, both the original expressions and the final one. And we see that for anything less than negative 5, everything will be positive. Okay, now even though this denominator is positive between negative 5 and 3, okay, the numerator is not. Okay, so even though the numerator is positive between 3 and 4, the denominator is not, or the other expression is not. And we see that for everything greater than 4, everything is positive. So here x has to be less than or equal to negative 5, or x has to be greater than 4. Okay, and of course we don't include either of these, okay, because it can't be equal to 0 either. Okay, so just to recap how to solve these problems is first of all to recognize that you can use the logarithm laws to simplify. Number 2, use your other methods for simplifying, such as factoring. And then number 3, make sure the end result and the original expressions are both valid for your x values. In this case here, we needed all the inputs to be greater than 0. Okay, that's it for this one.